Hello, in this video we'll cover the remaining part of the hypothesis testing. In the previous video we have done up to chi-square test and we have also done t-test. We did one sample t-test and independent sample t-test, and now we'll cover ANOVA, one-way ANOVA and two-way ANOVA. And one-way ANOVA is similar to the independent sample t-test, similar similar to independent sample t-test, and also gives same result if categorical variable has only two categories. And the main difference between these two techniques are ANOVA can handle categorical variables, which is also called binary variables with more than two categories, such as such as we discussed in the t-test, that the t-test can only be used if there are only two categories in the binary variable, such as let's take the example of gender. It can male or female. If the categorical variable have more than one categories, then we cannot use the t-test. In that case we must use ANOVA. Such as if we talk about religion, then religion can be more than two. It can be Hinduism or Christian or Islam and so on. And if we talk about places, it can be of multiple categories. It can be Williamstown, it can be North Adams, it can be Pittsfield and so on. There can be more than two categories. In that case we'll use ANOVA. And in this case the null hypothesis is that there is no difference between um, two areas. In this context, in our context, this is that there is no difference between two areas. It's Williamstown and North Adams. Williamstown and North Adams in respect to average age. In respect to average age, there is no difference between these two areas. This is the analysis for this ANOVA, one way ANOVA, and the syntax is ANOVA age area. If I run this, then we will see this result, and from here the main result that we should be concerned is the f statistics. If this value is less than 0.05, then the decision rule is same. We will reject the null, else we will not reject the null. We fail to reject the null. In this case this is greater than 0.05, so we fail to reject null, and the null is that there is no difference between the average age of two areas. And let's see its t-test. let's again do its t-test. Test is by area. If I run this part, then we can see that the f-test is actually conducting this test. And if we look over its value, then it perfectly matches. This is also 0.1 0.1910, and the thing that we found by the t-test is also same. And the other interesting thing is that this t value will actually be f stat equals to t stat whole square. If you do it, then you will get exactly same f stat, such as we can demonstrate it here. Since the t stat is t stat is minus 1.3167, let's display it and let's do its square. This square is 1.73369, and let's check its f value. It's 1.73, means that it's exactly the same. This is actually the square of t stats. And now let's go to two-way ANOVA. In the two-way ANOVA, we will have two categorical variables. In this case, we will have two categorical variables. In this case, we have area and gender as a categorical variable, and if we run this, I have written reg. Now this is not the description. We will write ANOVA is area gender, and if I run this, then in this case we have this result. In this case also, we will only look over its f value. We will look over this f value and f statistics. We will look over this f value and f statistics, and the decision rule is same. This must be less than 0.05 to reject our null hypothesis. And the null is that no relationship between area and age. There here our our interest is age. We have done with age, and there is no relationship between age and gender. This is the two of the conclusions that we derive from here. This result is similar to the result from the regression analysis. And if I do same, such as if I run reg, in this case we can see that, and we can also see that there is no any relationship between area and age, gender and age. And how we can know it? From t-test and the p-value. Since these two are greater than 0.05, we can conclude that area and gender do not have any relationship with age. And there is one there is on and one of the interesting observations, such as this t stat value is actually square of the f stat value. This f stat is 1.69 in this case. In this case it is 1.69, and in this case we are having a t stat as 1.31. I think it is for area, yeah, 1.31, sorry, 1.30, 1.30. And if we take a square of this, then it should be equal to 1.69. So now di 1.30 square, yeah, it's exactly equals to 1.69. So we can say that the one way, sorry, and we can say that the two-way ANOVA and the regression, or the simple multiple linear regression, will give the same result in our case. Thank you.